Welcome to Comp 2503, the linked lists and linked structures part 1, the basics video. In this video, we're starting our journey to learn about linked lists as a first step of building a data structure, but also as practice to learn about what I like to call linked structures, which is where you're taking chunks of memory and using these object references we've talked about before, pointers or memory addresses if you're dealing with other languages, and being able to link memory together and then start creating different structures and literally differently organized data structures to store and organize our information. So this is kind of like our first step to learn a tool, learn about linked lists, that then once we build these skills of how to work with the code and work with visualizations and abstractions, we can then step into a little bit more detailed, more complex structures and take what we've learned here and then move forwards. So this will be a series of about 3 videos where we start here just to learn the basics of what are these structures, how to reference and put stuff together. How do we use references? Like the next series will be then the video will be about how do we move a reference through these structures, and then thirdly, how do we start dealing first with a basic example of a linear list and use everything that we've learned in the first 2 videos to build a little bit larger of a structure. So if you want to on your own time, there's another little video of Too Long Didn't Read, kind of introduction to linked lists that I'm not going to play here. You can find the link in the slides itself and watch the video if you want, but it just talks about a lot of the same things that I'm about to go through. So in this course, I'm introducing the term linked structure. This is not as common out there. You'll find it in some areas, but I like to use it as an overall family of things when we talk about stuff where we're getting nodes or pieces of data that are then linked to each other through references. So those memory addresses to say which is the next one or other ones to go to. And so linked structures itself is a whole family of different things. So it's a collection of nodes and objects storing data links to each other. And then specifically under linked structures, you can get specific ones like a linear list or other formats. So a linked list is a linear linked structure. So it is a data structure composed of nodes or objects. Each node or object holds some information and a reference to another node or object in the list. And this is where we'll start getting different terms like singly linked list, which means this is linear structure, but there's only one link between the actual objects. You also get doubly linked list, which means that each node holds 2 links, generally one to the node that's supposed to come after it, and then one to the node that comes before it, which allows easily moving forwards or backwards within the structure. You can even get things like circular linked lists, which means that the ending tail, like if you think of one front end and the end, is this end loops back around. So the motivation for this is that it's very common in programming to group data together in a structure so that it can be processed. You've dealt with that, and it's the point of this course. So you're dealing with arrays, so you can group through lists of information that makes context to what you're doing, student records, information like that, so forth, and you need to deal with it. And so far, the most advanced way you've learned to store this data is an array list, or generally in Java, if you're starting, is an array list as an object, so it manages the growing and sizing and other things for you. And so this creates the idea of a list. In general, that like with an array or array list, it's like having things listed down on a piece of paper line by line, and then you can go back and forth and access each individual component of that. And so it's one way to organize your information that you can then place structures within it. So if we look to a computer science definition of a list, is that in computer science, a list or sequence is an abstract data type that implements a finite ordered collection of values, where the same value may occur more than once. And this is specific because sometimes you get other linear structures where it says you can only have a value appear once, and this depends upon the actual application you're using it for. So here you're just saying, yeah, I can have a sequence of them so that they go in some kind of actual ordering of each other that you think like a straight line, and you can have duplicate values in that list. It's just holding it and organizing into a linear structure. Now, if we look at an abstract kind of idea of an ADT of a list, you would have things like adding an element in some way, Removing an element can be variations of this, searching for an element, testing to see if a list contains an element, and maybe the size to see how many actual elements there are in that list at all. So a simple list or array, and being a computer science definition, is a data type that is meant to describe a collection of elements, values of variables, each selected by one or more indices, identified as their keys, that can be computed at runtime by the program. And so this just more means is that the memory that's needed for that storage is decided when the program is running in the very beginning. So right when it starts up, we know the size of an array. You're saying you give how the size of it. It allocates that memory all in one spot. You then have individual spots within there that you can store individual values, depending on the data type you associated it with. And you can access it through its index value that you're used to, like 0, 1, 2, 3, 4, 5. So advantages. Random access is quick. The idea is with an array is in memory, it's all one linear structure in the similar area, so to be able to jump back and forth is very quick. It's not hard for a program to actually do. And it groups like information together. Now, a bigger limitation of this is its finite size, is that when we talked about an array, not an array list, which is a wrapper around an array, is that when you have an array itself and you declare its size, that array at that time can say only be size n. So if we declare an array of size 10, that array at that time can only hold 10 elements. And if you want it to grow larger, you actually have to make a new array that's a larger size and copy everything from the original over to the new one. And be aware, this is happening inside of the actual array list class. Because in the state for an array list object, it actually has an array inside there, and when you're adding and removing or doing anything, it's managing the shifting and modification of all the data. So as you keep adding a lot of data to it, at some point in time, its internal state will get filled up, so its array, and it will have to go through a resize phase where it'll make a bigger array and copy everything over. You as the external on the outside of this object, the user, don't see that happening is because it's all encapsulated into the actual object itself, being that it's self-governing and doing its work. Now, another limitation for arrays is inserting or deleting data may require shifting information around, so increasing the time that it takes for an algorithm to actually run. Because, again, array lists, this is hidden from you. It's handled for you by the actual code itself and that object, keeping itself self-governing. But what really happens if you have an array and you're adding stuff, you need to write your code as a programmer to be aware and how does it get added. When I'm removing something from the list, do I shift all the data down so it keeps it consistent? Like what happens in an array list, that when you remove an element, all the elements that are after it get shifted back and have new index values. And so that takes a loop that will go through taking everything that's past it, shifting all that data back. And so you need to deal with it. So if you're storing stuff and doing a lot of very quick accesses and not doing a lot of inserting or deleting, then an array can be useful. If you also know the size at the beginning and it's never going to grow too big, then array can be your first starting point. Or if the size is starting small, that those resizing phases don't get too bad. But if you get where you have tons and tons and tons and tons of data, so like 1 million elements, an array is not going to be good anymore for 1 million elements to work together. If you have a lot of adding and deleting that happens, well then this can also be really bad if you're using an array and you have to shift everything around a lot while you're using that array. So a possible solution, and the whole point of these notes with linked structures and linked lists, is an alternate to an array-based implementation of a list structure, is to link the separate elements together. So, and the idea is that, well, instead of being one contiguous sequence of memory in the same spot, why don't we just get memory when we need to, but within each spot we say, okay, the next one is at this location, and the next one is after here at this different location. So physically in the memory, the data can be stored in multiple different spots, but each one then has a link to say who's the next and who's the next that follows after me to recreate that linear structure. Which would then allow us to do things like if we're adding, it could be very quick because we just make a new piece of memory and link it to one spot within that list. If we have to delete, we just have to get to the spot that we want to delete and then update the links of anyone before or after that to say who to go to. from there, but there's trade-offs and stuff like that, and we'll talk about it in the code, but it just all depends what you're doing, and this is the point of data structures. But a bigger question right now is, how can we do this? And like earlier on in the intro of the Java Old and New video, I introduced the idea of a reference or an object reference. And this is going to be how we'll be doing this in Java, is that we'll be creating object references and then properly setting those. So this is going to be a quick review of that original information. But you have to remember that a computer memory consists of what you can visualize as a long list of addressable memory locations. So a reference is a data item that contains an address. So again, an analogy being a card with an individual's home address on it. So it's still within memory, but at that location in memory, it holds an address to the next spot you're supposed to go to. So a visualization of this, again, is like this straight large structure. You have these memory addresses in hexadecimal, why we have these characters here, and this here would be some kind of actual data somewhere else in memory, and it would be containing the number of this address of where to go to. And the idea is with these references when they're marked in the language is that when you work with them, generally you'll see an object reference when you use the dot, it's telling the machine to actually take the address that you see in this variable, go to that spot in the memory, and apply it to the object that you can visualize kind of like being there. So an object reference is stuff you've always seen. You've always declared when you've made objects, so you've made your class, and you're instantiating the objects, you've always made a variable where it's the type of that class, you've given it some name right here, and this is your object reference. And this is a variable that in reality doesn't hold the object, it holds the memory address of where that object is created. Because this command that you see here again of being new bank account, that will tell the machine to go and allocate memory where that object will be, and it will give back the address. So the result of new here, this equation will give back an address of where that object is, and then it gets stored into your object reference. So in this code example, we can see that we have two object references, and we have two separate objects that are stored in memory with them saved within these variables. Visualizing it, like that very first line, again, I like to do it is I like to personally visualize objects as circles. I will keep then any data written inside here if I'm doing any tracing. I have the variable here with its name, and for 2 purpose points I've said this is the memory address you see up top, and then here's the memory address that's saved in the reference, and I will draw a line with an arrow just to show that this variable is holding an address to this object, to provide a visualization of all of this. And for myself, when I go to trace, then I know when I see code that says this reference variable, so act1 dot, then I'll mean, okay, I go from here and I follow it to the object and do the work against the object. If I see anything that just says act1 with no dot following after it, so I'm not calling a method or anything, that means I am just working with the reference that you see here. And this helps me keep track of everything without having to purposefully memorize all of these links. And this is where these arrows and the direction that things are will become very important. So again, going back to that original diagram before, if this is actually an object we're doing just to visualize it, you have your object reference variable, so that bank account act1 with the address in it, and at that address you can visualize ID the data for that object. That's where it's actually stored in memory. So this will become very important because now when we have to go to making link structures, we're going to have to make new objects, but then we're also going to have to work with object references. And the idea is combining both of these things together, something to hold it externally, but having this object have an object reference to another one. So an example of having multiple references to the same object, which does happen, you do it sometimes in your small code, but it's going to be bigger for these link structures. And this example here is showing, okay, well, I have 3 different object references, so act1, act2, act3. And then right here I have act1, first line is making a new account. So this will make a new object and store it in memory and store the address in here. Now after this, you can see I'm going like act2 equals act1. There's no dot, so I'm not saying go to the object that we created here. Instead it says copy the address that's stored in here over to act2. So what we will get after this line is that act2 is also referencing this exact same object. So anytime I go act1 dot, it'll go here to make the change, and act2 it'll go here to make the change to the object that was created. Now following here afterwards, the same thing again is Act 3 is copying what was in Act 2. Well, Act 2 was holding Act 1, so that same reference gets copied over. So the address, so these are three independent, separate like object references that now all hold the same address to this one object. So visualizing it here, it's using the way that I've showed before. You can see these separate three variables. They'll have their own locations themselves within memory. Then internal at that spot will hold the same address to this object. So now anything I do after this with Act 1, Act 2, or Act 3 will make changes to this one object there. And now here's the interesting thing that wasn't shown before in the previous notes, is the fact that, well, an object can also internally have an object reference. And you've seen that where you've made objects and internally their state then also has references to other objects. So here you can see if we made a chain of, well, having a reference variable that address to an object, and then this object internally has another object reference to another one, which you can see that building point of where we're starting to get to the linked structures. Now here is a code example of how to set up. So if we have this diagram, the same one we just saw before, how could you do that in code? Well, we'll start that I'll create this class node2, has something where we can store data in it, and then here is that object reference that I was talking about that we can hold to it. And what's very interesting is just because you got public class node2 here, it is legal in Java to then start using that as a type in this current class. And so what this means is that, well, this is a class definition, so this will be when a node2 object is created, it will have state in it where it can hold an object reference to another object of type node2. In the beginning here, I have it equal to null. Now null is a keyword in Java, and what that says, it's like blank. It means no memory address or anything. And so it's your general for references if you're starting out and it's not being assigned to reference to an object, it'll usually by default get set to null, or you can set it to null. And so this is like having an address card that's blank. So you look at it, there's no address, so it's blank, so you can put an address into it in the future or erase old addresses. We've got the get and sets to access and change these, and we've also got a set next, which will pass it in here. And now remember, this here, what you're seeing, even when it's a parameter, is not copying the object. In Java, this is an object reference, so it is just copying the address to the object that was passed in. And then we copy it over, come right here as well, that we're not going other dot. We are actually going next equals this, so copying the address in so we can connect these together. So if we go up to the main, and I'm going to go through as a quick example, but the slides next have a visualization of as well, is that we made one object reference called reference. We then say new node2, which will go make a new node of this class, and we'll store the address within here. So right now we have this going to an object. Now we're going reference dot, so this means like right here, is this reference dot will then follow and go over to object, which is right here because I've got the dot. It'll then go set next, which is this thing in here. I'm visualizing the node2 as this square box. And then what's passed in here is we're going again another new, making a new object from right here, and then the address of where that object is created is passed in. So going to the set next, going to the other, copied from other into next, which is what you see here, and you see that's going to the object that was stored. And so this was the one that was created right here. So now let's go through this as step by step for visualization. Now you're going to see this in a lot of the videos in the future, and a lot of people generally just gloss over this stuff, but this is important to start building up the fact that, okay, looking at the code, once you get practice, you don't need to worry about drawing out or visualizing it this way. You can understand what's going, but you can't just go purely on the syntax without understanding how is the current structure affected in this one here. So what you have first is the way I like to draw it is references I do as this box, objects I do as a circle, and then the null that you'll see is drawn by the line down like this with a bar underneath. A lot of other people draw it this way. So on this first line here, after it's done executing, we'll have the new created the actual object. So this object will be created, and that's where the next is made, and it's set to null. The address is then returned and stored into reference, so that's what's stored here, and I visualize that by this line right here. Once we go to the next line, this thing here will be executed first before the set next method is actually called. So a new object is created again, its next reference is set to null, and then you have the object, and then the address of where this object is in memory is returned to here and passed into the set next. So what happens here again is with the reference.setNext, it's the dot. So it's reference, it says dot. I follow the arrow that's currently drawn there. It says set next. Okay, that's the data that's right here is next. And we're passing in the new object that was created. That was this object here. So we'll draw a line coming down saying that, okay, the next inside this object is now connected down here. And the next inside of this one is still set to null because it hasn't been changed. So we have this little bit of a chain right here. We can't do much yet with it, like how do we move through it, how do we access stuff, but that'll be described in the following videos of moving reference, and then once we get to a full linked list kind of structured video. Okay, so from here we can now start to create chains of objects that are all linked together. We have one where we've manually done it, and most of the stuff here is going to be manual. In the future, you'll see where you don't need to have all these separate references to do it. You'll have a few, and we'll move slowly through these chains. Since we can see it here, there is a way that we can slowly start moving through them, following the direction of where the memory goes to access it like an actual list. So we have these, and we can keep adding chains to make longer lists. We can go in between and start changing these references around in proper ways to add in between. We can delete stuff and modify references so that everything still links together properly. And there's lots of tons of different variations of how you can do this. So here's an example where purely doing in code, and this is not the way you normally do it, but just to say how could we create this 3-node structure just using what we know so far. So if we start with the same node2 class where it's got an object reference that can connect to another object of its own type, the data and their set methods, we can start in the very beginning by having one reference that we create here. We can then make the first object that it holds, so the new, and then we'll make other references just to hold the other objects we want to add in here as we go. Just so that it's easier to see. Maybe I could have done this with one reference and reused it. But you can see here that we have ref1 adding ref2. So, and then setting the next. Now I'm going through it quicker on this slide because in the next slides we go through it step by step like we've seen before. So first, like we saw before, create the new object, which will do this and make the reference null for next. And then it stores it into reference, so drawing the line there. These next two lines will create two object references, and since they're not equal to anything yet, by default Java generally sets these to null, so that's why you're seeing the lines right there that say null. Next here we have it making a new reference and storing it in temp_ref1. So again here temp_ref1, arrow, the new object we have, and by default because the constructor sets this to null. Here we're going reference.setNext. So again, you're going reference dot, so follow the arrow, go here, access the next, and it's being made to then reference to what temp1 is referencing to. So temp reference to this object. So we draw an arrow to connect now, say that those two are connected. After this, we get temp_ref2 equals new node. So that's temp_ref2, new object here, stored in. Same thing we've seen for before. But now we're getting temp_ref1, which will go boom. Temp_ref1 dot follows over to here, change set next. That'll equal to what temp_ref2 is referencing. Boom. So you draw the arrow to connect these. And what we have so far after down to this line is a reference to this first one, and then this links to this one, then this links to this one, and we have two references right here as well. Objects right there. This very last line, then we'll set temp_ref1 equal to temp_ref2 equal to null. So this right here and this right here get set to a null. And so they're not referenced anymore, but what we still have is this structure here. So that you have the first reference and then this one links to the next, links to the next. And we're building up to what we'd want for a linked list, which is going to be a big thing where we can't have references to every individual object in this list in the future. If we have 1 million of them, we don't need 1 million separate references. We would just be having an array at that point in time. This is just for a starting beginning structure, just to make our own link structure, use these as temporary references, and then we're left over with, we have this first reference that was linked to here, and the idea is these are chains. So if I can get to this one, I can access its next, and then I could then access this one, and then I could access this one here. And so there's another property then for references that we can use to move through this, and you'll see that in the following moving reference video. Now, a very big thing about this is once you have all of these, is this first reference you have or any other key references, you don't want to lose or change them. If you modify this one out of the order, you're doing anything else, like suddenly this reference equals to something else, before you've kept this, you'll lose all of these. They'll just float off as we need. So this very first reference to the beginning of your list, and maybe if you have one to the end, is going to be massively important that you maintain and be very, very careful of what updates you do when you're working with this one. Now I have a small class activity where I'm going to go code this live. There is a solution on the next slide, as you always expect. Is just given a challenge of, okay, that you want to create code that by the end of its running in this main, that you have this current structure. So you can use two references. The list second reference must be null by the end. First reference to one object, and you kind of get this circular structure that's happening. Okay. So let me escape out of the slides, and then let's go to the code. So all of this code is always can be found in the course Google Drive and in the course Blackboard or wherever it's posted. You will find it numbered very similar, named similar to these actual notes. And so you have the solution there. So here we have, again, the Node2 class that you've seen here. It's got data. It's got data, it's got the next, the get next, set next, all of that fun stuff. And then we have the start blank main. So the very first thing is we want to make our references. So your reference in tempref. And so I'm just going to make these, then we'll update these when we come back first. Okay. So I have now made the reference and then the temp reference right here. Next, now I want to do this first one where at least I can make this object. And we can even do this now is that we're going to need both of these actual objects, and then we can deal with linking both of them together through these nexts. So I will modify these lines now to make the nodes. So new. So again, this line here, the spot here, will actually allocate in memory, return the address and store it in here. So that will then create that we made this, and then we have the arrow to it. So we're good. And then the next one. This will then make the reference, it'll go to here. So we're not done yet because this has got to be null at the end, but we want to make this object. And so far what we have is this object here, and we have references to each one. Next, what I want to do is I want to take what is reference, and I want to do this line that's right there. So I want to get this object, access its next, and set it down to this object here. So first we go your reference dot, so that we go from here going to the actual object. I want to access the next variable in its state, and the one thing that's provided for that is a set method for the next right here. And what I want to do is I want to make a reference down to this object, and currently that's being held inside of this object reference variable right there. So boom, there you got your first line. So this will make both objects. We have the reference here. This reference.setNext will now make this reference down to this new one right here. And what we need to do next is then take this object and make it reference back up to this one. So currently we have, again, tempref accessing this one. So we will go tempref dot take us over to the object here, set the actual reference we want. We want it to hold the one up here. We know reference is holding the address to that one. Right there. Okay, so we're almost done here. So we've now made reference to here, this link down to here, this link up to here. But now we've got to modify it, well, because here in the end it's supposed to have that tempref is referencing to nothing, so being to null. So then we go tempref equals null. And there we go. that gets us setting up that reference. And you can see kind of why I'm doing this is the challenge of, well, looking at this code directly, you may not see this structure in here by the end, but this is why you have to use to not just look at this syntactically and semantically, but you have to understand what's happening in the machine behind the scenes, and you have to draw out on paper, on a board or whatever, this visualization, or visualize that in your head. So a little bit of an abstraction. Okay. Let's go back to the slides now. And you can see here's the solution, just like we coded up ourselves. And if we step through this slowly, just again see the visualization step by step instead of just hearing me talk about it. First line, node ref equals node 2. So node ref, new object, null. Second line, temp ref, new object, this is null. Third line, reference dot, so reference, go here, dot, follow to where it's currently the arrow's pointing to, dot set next, access to here, reference to what temp ref one is, so this temp ref is pointing to this object, so this one will also point to the same object. Temp ref dot set next, so temp ref dot follow here, dot set next is the reference. Reference is currently pointing to this object, so next is taken and referenced up to here. And then finally, temp ref 1 equals null. Then temp ref 1, we draw it out here to say that it's not attached to anything right now or not arrow. So if I try to go temp ref dot, it'll crash because this is null because there's nothing to follow it to. So boom, done. Not too bad. Now here is another class activity where I'm going to go through, and this is doing the opposite, is given some code. So that same we know here from node 2 class we've been working with, what is the actual structure that's created by the end of this code? So I am going to switch to my handy dandy OneNote and draw this out, not in the most steadiest of hands, but I will draw it out line by line what's happening. Following on the slides after this is another visualization that I will then go through. Okay, so first line right here, we have node reference. So I want to draw a box and ref. So I'm just going to ref. So that is node 2 reference. We then now have the new node 2. So we will get an object out here. It will have its next reference inside here, and it'll be null by the beginning. And then the address is returned back, so reference will be pointing to that one. Next we have temp ref 1 equals null and temp ref 2 equals null. So I will go tref equals null and tref2 equals null. So we've got these three lines done. After this, next modifying it is we get temp ref 1 equals a new node. So I can then draw the new object that's being created. It's got its own state for the next variable, which will default to null. Then I can erase that the temp ref is now referencing over to here and not null anymore after this line right there. So node 2. Following this is reference.set next. So we are going to reference right here, going dot, accessing this n right here for next, and it's being set to temp ref 1, which is here. So this means that we can now erase this line, and that means that we are referencing down to that one. Okay, so we've done this here. Temp ref 1 equals node 2. Reference.set next here. After this, now we get temp ref 1 equals a new node. So we got to be careful here. So we got to go down. We are going to make a new object, n, that's null. It then says that's stored into reference 1. So currently that temp ref 1 is going over here. So now since we're reassigning the value, that original link is gone, and now it's going to the new object that we created just now. So that is right there. This is then saying that temp ref 2 equals reference.getNext. So we have reference, go dot, right over here. This is saying get its next. That next is pointing down to right here. So your reference 2 will now be up to that one right there. And then finally from this, we're saying tempref2.set next to what tempref1 is referencing to. So we go tempref2 dot up to this object. We go dot next, and now that's referencing to what tempref1 is currently referencing, which is this one down here. And so we have this current structure, and that's after this line right here. Boom. Now following down to this one here is we go tempref dot. So again, here to the tempref, go dot down to this one. It's saying dot set next to what reference is referencing to, which is right here, and references this object. So we can go and change the reference here at the bottom to the top that you see up here. And then finally tempref1 equals null. So that line right there disappears, and this is what we're left with at the end. So at the end of this code, we have referenced this first object. We have temp_reference2 is referencing to this one, and then this object is down to here, this object reference down to here, and then this object circles back up to here. So this is almost creating a linear link structure. Circular, sorry. It's a linear structure, but it's a circular at the end goes back to the start. So you can see, now if I switch back to the slides, is that looking just at this code, you're not going to see that exact visualization. So this is drawn a little bit differently, but you can still see that same structure. tempref1 is not here, tempref2 is up here, and you get this kind of circular structure. And the realize is just directly looking at this code, unless you have experience, you're not going to know that by the end of it that this is what's been done in memory. And so you need to get used to, when you're writing code, is either drawing these out first and making your plans of what you need to do and then turning that to code, or when you're looking at this code is try to draw out what's happening step by step and making changes to the current link structure you have based upon the current line that you're at. So just to go through this again so you can see the visualization of it building up, and I'll go through it a little bit faster since we've already done this, is that you have node 2 reference equals a new node. So new object created, this is null, reference to it. You get the two temp1 and temp2 references that are set to null. Temp1 equals a new object, nothing is linked together, but you have the null for this one, reference is here, temp2 is still null. Reference dot set next equals what tempref1 is currently referencing, which is this one right here. Tempref1 after this line here now equals to a new object, and so far we have reference to this object down to this object. This is still null. This is referencing up to this one here. Tempref2 equals to, if we follow here, reference here, dot get next gives this address, so that is pointing to this object. So temp2 will reference this object up here. Then we go temp2 dot set next to tempref1. So temp2 dot follow where the arrow currently is here, dot set next. Follow saying, okay, tempref1 is reference to this object, so the next here goes over here. And then finally tempref1 dot set next, it's actual to reference. Reference is referencing the object that's right up here. So tempref1 is going up to this one. And then finally the null. So that we have this kind of circular structure that's been built with these two object references still holding on to parts of that structure itself. Okay, so that's the end of these notes. It's kind of quick. That's your first level just to get the idea of references and objects and getting used to doing visualizations of this. And this should take more practice. Like, go play with that code. Try to draw out different object references on a board and think, how would you write the code that would create that structure by the end of the actual main? And take that as a challenge to yourself to get used to, okay, well, how would this look in code? How can I deal with visualizing this and drawing everything out? Other than that, I hope that you're all doing great, and then you can now move on to the moving references notes.